And these are the integrated one notes for our first section on exponential growth. So we're in 5.1.1. The notes have been attached to the daily agenda. So what you see here that's already typed out is also available for you. It was linked to the agenda last class. So hopefully you printed it out if you wanted to have it. If not, you can go ahead and just take these on your note paper. All right, so here we have a situation. And we're going to take a look at the situation here. So we've got Lenny and George. They're going to start with 2 rabbits. And then during the first month, those rabbits have 2 babies. We're going to suppose that this happens from every month from here on out. So every pair of rabbits is going to have 2 babies. We want to draw a diagram. Now, there's a whole bunch of different ways to do this. And we are considering the total number of rabbits is growing each month. Okay, so how many rabbits will Lenny and George have after 3 months? All right, so there's a whole bunch of different ways we could draw these diagrams. So I'm just going to say in the beginning. So in the beginning, no months have gone by. We just have rabbits, or Lenny and George have rabbits. And I'm just going to call them Rabbit 1 and Rabbit 2. Okay, now let's talk about the next month. So month 1. In month 1, those 2 rabbits we started with, Rabbit 1 and Rabbit 2, are going to breed. And they are going to have 2 rabbits. So Rabbit 3 and Rabbit 4. Okay, now let's talk about month 2. We think about how many rabbits we had before. Well, we had Rabbit 1 and Rabbit 2 as a pair. And then now we've got Rabbit 3 and Rabbit 4 from the previous month as a pair. But those pairs are also going to breed. So now we're going to be talking about Rabbit 5 and Rabbit 6 and Rabbit 7 and Rabbit 8. All right, that's month 2. Okay, let's talk about month 3 now. Now we still have all the rabbits from the previous month. So we've got Rabbit 1 and Rabbit 2, Rabbit 3 and Rabbit 4. Then we still have Rabbit 5 and 6 and Rabbit 7 and 8. But now they are also going to have more. So now we've got Rabbit 9 and 10, 11 and 12, 13 and 14, and 15 and 16. Okay. Oh, forgot the rabbit part. So I should be able to figure out now how many rabbits will Lenny and George have after 3 months. Okay, so that's the 3-month section here. And since I numbered them off, it looks like they're going to have 16 rabbits. So 16 rabbits after the 3rd month, or at the end of the 3rd month. Okay, let's take a look at the next one. Organize the information in a table showing the total number of rabbits for the first several months. Okay, we've got to do 6 months. What patterns can we find in the table and describe the pattern of growth? Okay, so I think I'm going to organize the information that we have from the beginning. So it looked like, so I'm going back up to the writing that I just did. It looks like the way that I set this up is that all the stuff on the left-hand side, so I'm going to go ahead and highlight that in green. All of the stuff on the left-hand side represented how many months. So month number or number of months. Okay, so let's organize our table here. So I think this was number of months. All right, let's go back up there. And it looks like the right-hand side, well, this represented the number of rabbits that I had. So the total number of rabbits at the end of that month or after that month had elapsed. Okay, so this is the total number of rabbits. And I think I can just grab the information from the work I've already done. Maybe we can find a pattern here. Let's see if we can sort it out. Okay, so the number of months, well, in the beginning, so nothing had happened. They just got some rabbits. They started out with 2. Okay. After 1 month, okay, I'm going to go back up and I'm going to take a look at 1 month. So 1 month, I'm going to highlight it in orange. So month 1, that looks like I had rabbit 1, rabbit 2, rabbit 3, rabbit 4. So 4 rabbits. Okay, so back down here, so 4 rabbits. All right, month 2, okay, back up. Highlight that in orange again. Month 2, looks like they had 8 total rabbits. Okay, so let's put that in our table. Then month 3, oh, I could have just highlighted my answer. I had 16 rabbits. So month 3, that's 16 rabbits. Okay, let's take a look at this. I'm going to take a look at the total number of rabbits, and I'm going to see if I can figure out what's happening here, like how this is growing. So previously we did things that were arithmetic, so it looked like we were adding something repeatedly or subtracting something repeatedly. This doesn't look like addition to me. This would just be, if it was addition, then that means these would all be plus 2, but that doesn't work for the 4 and the 8. So I don't think it's addition. I think this is actually going to be multiplication. So we're going to multiply by 2. So I don't think we have to actually write out all of the rabbits for the next ones, because I think we still had to do 4, 5, and 6. So I think if we keep multiplying by 2, oh man, that's a lot of rabbits. Keep multiplying by 2. I think that's going to give us 128. Holy smokes. Okay, lots of rabbits. What is the pattern in the table? Well, it looks like the number of rabbits is doubling each month. Number of rabbits is doubling or increasing by times 2. So increasing by times 2. Describe the pattern of growth in words. All right, there we go. So we found the pattern. Looks like it's multiplied by 2, and the number of rabbits is doubling each month. All right, let's keep in mind that information. Let's move on to the next part of the notes. Use the pattern to determine the number of rabbits that Lenny and George would have after 1 year. Okay, so we left off at 6. And then I think maybe we can start writing an equation. I think that's what I want to do. So I'm going to pull the information from the previous slide. So go ahead and take a look up at your notes. When I had 0, I had 2. When I had 1, I had, okay. This would have been times 2 here. So I'm not going to write it as 4. I'm actually going to write it as 2 times 2. So my pattern here, I'm going to put it off to the side in purple, is 2 times 2. Actually, I'm going to use parentheses, times the previous answer. All right, 2. Okay, times by 2 again. So it's going to be the previous answer. So I'm just looking above here. So there's my previous answer. And that got times by 2. Okay, so 3 times by 2 again. So the previous answer, I'm going to highlight that now in yellow. So there's my previous answer, and that got times by 2. Okay, same pattern. So I would actually just keep multiplying by 2. Let's see if I can figure out a pattern here. Previous answer. Previous answer, previous answer. All right, let's see. Well, I think I can take a look at this. Let's see. This would have had 4 2s in it, and there's a 4 right there. This has 3 2s in it from the previous answer. There's a 3 right there. And then I have that extra 2 out in front. Okay, I think I can generalize this. So I think what I can do is the previous answer. Okay, so I want to figure out what, 12 months? Okay, 12 months. So 12 months. I think that's going to be 12 2s, because that would have been the previous answer. 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. But then I would still have the 2. Now, I would get the exact same answer if I went through and did this. But if I'm looking at this pattern right, I think that, well, I don't know, let's take a look at the previous slide and make sure this actually works. To get to the 6, I would have multiplied by 2. 1, 2, 3, 4, 5, 6. So I would have taken my original 2 and multiplied it by 6 2s. So this would have been 2 times 6 2s. Okay, so 7 2s, so 1 more than what I had. All right, I think that works over here as well. Now, let's think back to the exponent stuff that we just did. If we take a look at this, inside, that was 12 2s. So that would have been 2 to the 12th. But I have another 2. So let's bring that down. So that would be 2 to the 1. All right, reviewing what we know, we would add the exponents. So I think that would be 2 to the 13th, which we would definitely not have to do without a calculator. So grab my calculator. We would do 2 to the 13th power. Okay, so this is 8. Wow, that's a lot of rabbits. 8,192 rabbits. Okay, so we ended up with this 8,192 rabbits. That's a lot. But we were also able to rewrite it as 2 to the 13. We were also able to write it as 2 times a whole mess of 2s, and 2 times 2 to the 12th. I think those are going to help us in a little bit. Okay, a geometric sequence. This is a lot like the arithmetic stuff. We can generalize this, but this is repeated multiplication this time. It's not addition or subtraction. So what we're talking about here is we have this multiplication generator. It's got a couple of names. It's called the common ratio or a multiplier, either of those. Okay, our formula for this, our explicit equation, let's go ahead and box this in red, is T of n is equal to a times b to the n. Now, the a and the b represent different things this time. The a is still our 0th term, and b this time is the multiplier or the common ratio. So a little bit of introduction to that. We're going to spend a lot more time on this, though.